All right, we are live. Okay. So, trying to find some math problems to help with on the homework help subreddit. Sequences and series. I suck at sequences and series. Ugh. How do you do question 2? Solve the following equations for all values of theta in the domain stated from negative 316 to 720. Okay. Oh my god. All right. I'm going to work on this one. Two comments. So these are the auto moderators. So let us share the stream here. Okay. Did I put it on the screen? All right. So let me actually. Hey baby, can you hand me my cell phone? It's right there. I'm live streaming. Yeah. Unless you wanna.
No.
Unless you wanna break the internet with a sweet kiss.
No.
You know, you don't wanna be on the internet. Oh, my friend from college texted me. Okay, so we're about to start this problem. I just want to make sure that I am actually streaming what I want to stream, so I'm going to pull up the video. All right, where are we at? I'll go to my own channel. Yeah, there's my stupid face. Okay, we live. All right, so let me add this image in here so I can work on this problem. Boom. This is the question we got. Sorry, my computer is really slow. There we go, here we go. We want to turn this sideways and then shrink it a little bit. We don't need it to be that big. All right, and really, we only want, come on now. We only want question 2, so I'm just going to get rid of the rest of this junk. Okay. The side of it was really cool. So let's move this one up here. Okay. There we go. All right, so we are gonna solve the following equations for all values of theta in the domain stated from negative 360 to 720. So it's really important at the end of this question and this is my final step for every problem I ever do. I hate using steps, but this is a step. Okay, is ask yourself, did I solve the problem? All right. So you would then go back to the problem and check to see that you met all the conditions that they asked you to meet. Hey, if you're in the chat, say what's up. If you have questions, please stop me. Let me know, okay? So the first thing we're going to do is we got to keep in mind that we are going to need to be from negative 360 to 720. So let's imagine I went backwards 360 degrees, and that's where I started from. And then so I go forward. Okay, now I'm at 0, and then now I'm at 360, and now I'm at 720. So we have a lot of actual periods of these sine and cosine. Oh, we got tangents in there as well. A lot of cycles of these functions, and that's really annoying because you're going to see eventually we just get reference angles. Okay, so let's start with sine of negative 0.5. Sine theta equals negative 0.5. I'm going to write this as negative 1/2. Okay, now the best way to do this is to use the unit circle. This is on the unit circle. So you need to be pretty familiar with your unit circle in order to recognize that. You could also go to your calculator, but without that understanding of the unit circle, you're not going to understand the periodicity of sine. Let me write that word. Periodicity, all right? And you won't be able to generate the rest of these solutions in that domain, okay? So let's use our unit circle as a tool. I'm just going to draw a circle here because this visual helps me a lot to like reference the diagram which is in my mind now. Okay, since I've done a lot. So we know that the sine is the y, right? If we have an ordered pair that falls on the circumference of this circle, okay, and that ordered pair would be x, y. It'd be given, since it's the unit circle, it'd be given by cosine of theta, right? The inscribed angle is theta here, and the y coordinate would be given by the sine of theta. So we need to think about the height of this point. So the one where the height is 1/2 is down here, and that's 30 degrees, or pi over 6. So this is the angle that we need to care about. So pi over 6, or I should say pi's over 6, right? It's going to be some multiple of pi over 6. So let's draw this angle here. This is approximately pi over 6. And it's the y value that I care about. Now, here our coordinate is root 3 over 2, 1/2. But we want it to be negative 1/2. Where is y negative? Where is y negative? Y is negative in the third and the fourth quadrants. Okay, it's below the x-axis. The y values are negative down here. So we reflect this across the y-axis, and we get this one right here. Okay, it's also negative in the third quadrant. So these 2 points. So let's think of theta being between 0 and, so they're giving it degrees. I'm going to do it in radians, and then we'll convert them all to degrees after. Between 0 and 2 pi. So the first circle around, okay? This angle, all right, let me actually call it from the x-axis to the terminal side there. This angle is going to be pi plus pi over 6, okay? So first angle in this domain is pi plus pi over 6. Now this angle here, where it goes all the way around to this guy, is pi over 6 back from 2 pi. So if you went a full circle and then backed up pi over 6, it would be 2 pi minus pi over 6. Okay, so these are the 2 angles in this domain, right, which is the normal period of sine and cosine that you care about. All right, so let's keep that in mind. We're going to figure out what these 2 angles are, and then I'm going to show you, using the periodicity of sine, how to find the rest of these in the negative 360 to 720 range. Okay, so let's add these 2. This is the same. We get a common denominator here, right? 6 over 6 is 1, so I can always multiply by 1. So this is the same as 6 pi over 6 plus pi over 6, which is equal to 7 pi over 6, okay? So that's one angle. That's that one in the third quadrant. Now, 2 pi minus pi over 6, we have to do the same thing. We've got to get a common denominator. All right, 6 over 6. So 6 times 12 is 12 pi over 6, right? So 12 pi over 6 minus pi over 6 is equal to 11 pi over, over 6. Okay, so these are our two like base angles, and everything else will be a reference angle with this. And if you don't understand the idea of a reference angle, please drop that in the chat. Okay, so we have two angles here. Let's kind of collect what's going on here. Let's collect these guys, and then we will find the reference angles for these. So 7 pi over 6 and 11 pi over 6. That's what we're dealing with, okay? All right, so these are in the first circle, so between 0 and 360. So I need to find the two reference angles, the reference angle with this one and the reference angle with this one, which are one revolution behind. That gives us in the negative 360 to 0 range. Stop me if that doesn't make sense. Give me something in the chat. Let me know you following. Okay, so I need to subtract 2 pi from this. I need to subtract a full circle from this. I need to subtract a full circle from this. That's going to put me in that period. So let's put those in there. So 7 pi over 6 minus 2 pi. So same kind of process. We got to get a common denominator. All right, and if you were doing this in degrees, you would do whatever this is in degrees minus 360. Okay. So we're subtracting 1 period of sine from this. So this is going to be 7 minus 12. Okay, so 7 minus 12 is negative 5 pi over 6. So this is going to be one of our angles. That's going to be in the negative 360 to 0 range. Okay, oops. All right, so then we're going to find the other one, which is the reference angle in that cycle to this one here. Okay, so same process. 11 pi over 6 minus 2 pi. This is one cycle of a sine function. That's where I'm getting that number from. And then I need to get a common denominator again, 6 over 6. So here's the denominator that I want to have, and I'm multiplying by 1. That's the trick, okay? 11 pi over 6 minus 12 pi over 6 is equal to negative pi over 6, okay? So this is going to be in here. And you can see also that that's in that negative 2 pi to 0 range, which is the same as negative 360 to 0. Okay, so now we need to go into the next cycle. So we did 0 to 3, we did negative 360 to 0, we did 0 to 360, and then we actually started with the 0 to 360. And now we need to do 360 to 720. Okay, so we're going to take these angles, those were our base angles, and we're going to find the reference angles in the next cycle by adding 2 pi to them, or adding 360 to them. Okay, so 7 pi over 6 plus 2 pi, which is equal to 360 degrees. Now we need to get that common denominator. This is, we multiply by 1, choosing the denominator that is common here. Okay. So 7 pi plus 12 pi over 6, so 7 pi over 6 plus 12 pi over 6 is equal to 19 pi over 6. Okay, so that one goes in there. And then lastly, we need to do the same thing for 11 pi over 6, okay, to get the other one. So 11 pi over 6 plus 2 pi, that's one cycle of sine. And we need to get that common denominator again. This is 12 plus 11 is 23. And so these are our answers. Okay, so those are the solutions to sine of theta equal to negative 1/2. These are the thetas that solve that expression. These are the thetas that solve this expression. So if I plug any of these into theta here, and you can try this on your calculator, put it in radian mode first, okay? Plug those in for theta. They will get negative 1/2, all right? So now this gives it in degrees, so let's answer these in degrees. We can convert all these degrees. So the way that we're going to do that is we're going to multiply each one of these numbers, each one separately, you're going to multiply by the conversion factor. So we know that pi equals 180 degrees. And so we have this in radians, so we'll divide to cancel radians here. So this equals 1. So 180 degrees divided by pi is equal to 1. Okay, we can always multiply by 1. It doesn't change our quantity. It just changes the way it looks. So I'm converting this one using that converting factor that we just figured out into degrees. Okay, so now we just make this multiplication. We can cancel and we can cancel. Now this has a factor of 6. This also has a factor of 6. The other factor is 30. Okay, so 6 cancels here with 180 and we get 30. Now we multiply 30 by -5 and we get negative 150 degrees. Okay, so I'm going to collect all of these as I convert them for you up here. So these are the converted values, negative 150 degrees. Okay, so now I'm going to do negative pi over 6. Negative pi over 6 times 180 degrees over pi. And you may prefer to work with degrees. I don't. Once you get comfortable with fractions, you're going to prefer radians as well. So the pi's cancel, right? And then here we have a factor of 6. This also has a factor of 6 and 30, and so this becomes negative 30. Okay, let's try 7 pi over 6 next. Okay, so we've got 7 pi over 6 times our conversion factor, pi over 180 degrees over pi. Same cancellation here. And so this is 7 times 30, which is 210. Okay. And then, okay, this one here, 11 pi over 6. And so whenever this video is finished, you can go back and replay it. If I'm going too fast, I am going kind of fast. And if I am going too fast, please stop me and ask questions. We're going to multiply again by our conversion factor. Boom, boom, and we get another cancellation. It's the same one that we've been doing. 3 times 6 is 180. You can see why this is like easy for me to do because I've done it a million times and seen it. Okay, so this multiplication, we're going to get 300, right, plus 30, which is equal to 330, right? Yeah, no. Yeah. And this goes to here. So we'll collect that one, and that was our 11 pi term. Okay. So now let's do 19 pi. Same factor. All right, this is always how we're going to go radians to degrees. Even if this number didn't have a pi factor in it, it could still be in radians if it doesn't say degrees. Like you can have 1 radian, right? It doesn't have to be a multiple of pi. Boom, boom, cancel, cancel. And 19 times 30 is 300 plus 270 is 570 degrees. So 570, and then our last one should be very close to 720. So that should be 30 less than 720, so it should be 690. Let's see. 23 pi over 6 times our conversion factor. And this is a lengthy problem. You'll be able to do these in your head very soon, but I'm just showing all the work for you. So this is 600 plus 90, which is 690, which I think is what I said. Okay, so here you have your answers in degrees and in radians for the first. Now I'm gonna go kind of fast. I'm gonna do the rest of these with less explanation. So stop me. I see that you're in there, but silent. So stop me if this cosine one goes too fast. All right. So now let's draw our unit circle. Actually, I'm going to draw a nice circle because I've got this really cool software, which is free. And if you are a YouTuber that does math stuff, let me know and I'll teach you how to do this setup. Okay, so here is our unit circle. Whoa. Okay. Here's our unit circle. And so where is cosine equal to 1/2? So before we had, this was our angle pi over 6, and we had 1/2 was the sine. So we want to go to the complement here of pi over 6, which is pi over 3. And this gives us 1/2 root 3 over 2. Okay. Now we want a negative 1/2. This is negative 1/2. So we want to know the thetas where cosine of theta is equal to negative 1/2. Cosine is negative in these quadrants, 2 and 3. So we want to reflect this across the y-axis and then reflect it down here. And these will be the angles that give us cosine of theta equal to negative 1/2. So if that does not make sense, please let me know, because that's actually the major skill here. The rest of it is just finding reference angles, okay? So we got to figure out what this is. This is pi over 2. This is pi over 2. And we're going to go an additional pi over 6 to get there. Okay, so this angle is pi over 6. This angle is pi over 6. So this angle here, let's call that one theta. This one can be phi. The big angle will be phi. So theta is going to be pi over 2 plus pi over 6. And these are our reference angles for the first cycle of cosine. Okay, we're going to do them again, and we are going to subtract and add 360 to everything. Actually, why don't I just do these in degrees? I'll do them in degrees because you might like that better, actually. So let's call theta equal to 90 degrees plus, here's 90 degrees up here, okay, 90 degrees plus 30 degrees. And then phi is going to be, this is pi, well, you can go to 270 and then back 30 degrees, or you can go to 180 plus 60, it's the same thing. So let's go 270 minus 30 degrees, okay. So these are going to be our two reference angles. We'll do everything in degrees so we don't have any conversions on this one. This is going to be 120 degrees. This is going to be 240 degrees. Okay. So let me collect those in a list here. And we can start finding our reference angles. Okay. Or coterminal angles, I should say. These are reference angles. We need coterminal angles. So let's find the coterminal angle for this. That is in between negative 360 degrees and 0, okay, the previous cycle of sine. The way that we do that is we take 120 degrees minus 360 degrees, and this will be negative 240 degrees. All right, so negative 240 degrees will give us that angle. And then to find the other one, same process. We're going to take 240 minus 360. This is negative 120. Okay. And we can see on our unit circle that if we go back 120 degrees, we'll end here. And if we go back 240, oh, did I make a mistake? Did I make a mistake? I may have made a mistake. Boom, 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 boom. So we wanted, oh no, cosine's negative. Okay, so yeah. So we want this angle and this angle, so minus 240 gives us 180. Yes, we're good. And then 90 and 30, yeah, we're good. Okay, sorry. And then same thing, we're going to take 120 degrees, which are our reference angle. Both of these are reference angle, and we're going to add one cycle to them and get 360 degrees. Add 360 degrees, which is one cycle to each of them. And we will get 480, and we will get 600 degrees. Yes, and so 480 degrees and 600 degrees. So this is the final answer without the step for, we just did it straight in degrees that time, so we skipped all that converting. And so you'll be able to replay this later, so I'm just going to keep trucking along unless you want me to slow down. And okay, so tangent of theta is slightly different process. Okay, slightly different process. So let's look first at tangent of theta equals -1/3. We know that tangent of theta is equal to sine of theta over cosine of theta. And just from like having thought through this problem a few times, I know that this is going to be -1/2 divided by √3 over 2. And what you get is you get -1/2 divided by, okay, bringing back the divided by symbol, 3 over 2. When you divide by a fraction, you multiply it by its reciprocal. So this is -1/2 times the reciprocal of √3 over 2, which is 2 over √3. Then you get this cancellation here, and this equals -1/√3. So let's take a second and follow that work. Make sure that makes sense, okay? So I need to find the angle where sine of theta is -1/2 and cosine of theta is √3 over 2, okay? The other way that you can get this, is if you have sine positive and cosine negative, okay? These two fractions both equal this, but two different angles can make these, all right? So we want, so let's do a unit circle up here. So sine is equal to -1/2 here. I'm sorry. Sine is equal to -1/2 here and here. And let's do cosine equal to √3 over 2 here and here. Oh, I put the wrong angles. I'm sorry. Okay, so sine is -1/2 here and here. Okay, and then and then cosine is √3 over 2. √3 over 2 here and here. And then let's do blue. So then working with this fraction, sine is 1/2 here and here. And then let's do green. No, that's not contrasting enough. Do purple. Cosine is -√3 over 2 here and here. So we want the pair of this and this. Those are the two cases. Let's do a sanity check. What quadrant has a negative tangent? Okay, quadrant 2 and quadrant 4. The sine, and when I say sine, I mean the sine of sine and cosine, has to be opposite of each other. So here we have positive sine, negative cosine. Here we have positive cosine, negative sine. That is when we get a negative tangent. We have to have an odd number of negative signs. Here they're both negative, so negative times a negative is positive. Here they're both positive, so positive times a positive is positive. But our tangent is negative, so it has to be either in quadrant 2 or quadrant 3. Okay, so with that little picture, we know that this is, are we in degrees? We're in degrees. So this is 30 less than 180. Let me change this color. This is 30 less than 180. And this is 30 less than 360. Okay, these are our reference angles for part C, 150 and 330. Okay, so let's think about this. So I'm going to draw for you the tangent function. Okay, this is off the unit circle, right? This is onto the xy axis. These things here occur at 90, negative 90. So we're in, which cycle are we in? 150. Okay, so we are, let's do one. This is 180. So it's 90, so halfway in between these guys. This is 135. Okay. Oh, something feels wrong. Let me check my process here. Okay. So 150. So there's 0, pi over 4, pi over 2, 3 pi over 4, pi. This is pi. So that means okay. Oh. No, that doesn't make sense. Bear with me. So we have asymptotes at the, so this is the axis. Asymptotes, asymptote. This is 90. Another one would be, this is 135. Oh, no, it's pi. So this is, okay. 270, which means 90, this is 180. Okay, so here's our 0. Here, our tangent kind of repeats like this. And so when we're at negative 150, or when we're at 150, we're here. And then so if we go pi back, we'll get to the other negative, or pi forward, we'll get to this negative, or I should say 180 for this. So I drew this to show you that our period for tangent is actually 180. It's not 360 like sine and cosine is. And that's something to convince yourself of. We won't get into, like, just graph tangent on desmos.com/graphing. Just go here and type in tangent of x, and you'll see it, right? That's pretty easy to see. Okay, so being that instead, like sine and cosine have periods of 2 pi, or 360 degrees. Tangent and cotangent have periods of 1 pi, which is equal to 180 degrees. So we're going to use the same method that we did before, but this time we actually have to keep in mind that our period is different. So we need to figure out the angles that are between -360 and 0. Okay, so let's subtract 180 from 50. And this is -30. Is this -30 in this interval? Yes. Okay. All right, let's use this one, and we'll subtract 180 from that. Okay. That's one period of tangent there. This is going to give us -210. Is that in this interval? Yes. Okay, let's try and subtract 180 from 210. This is going to be 390. Is this in this interval? No, this is not in that interval. So that is that angle will make this true, but it's outside of the domain that they asked for. So that's our smallest angle. Okay, so now you'll notice that 150 plus 180, 150 plus 180 is actually equal to 330. Okay, so this angle's already included. That's by virtue of our period being 180 instead of 360 like it was before. Okay, so let's just add 180 to this guy. 330 plus 180 is equal to 4, 5, 10. Okay. Is that in this interval there? Yes, it is. So go there, and let's do the same thing with 5, 10. Let's add 180 to that. This is equal to 690. And is that in this interval? Yes, it is. Yes, it is. And then let's try 690 plus 180. This is 870. 870. And is 870 in this interval? No, it's greater than 720. So that doesn't solve our constraints for our problem. Now, that angle will give you a -1/√3 for tangent, but it doesn't solve the conditions of our problem. So this is the solution set for problem C. I see you're still watching, so I'm just going to keep going, even though you probably know how to do the rest of these. Okay, so sine of theta, we're doing part D now. Sine of theta equal to -1/√2. So I've been doing this trick where I multiply by 1 because 1 doesn't change it. The quantity stays the same, but it may look different. And this is a common technique when you have an irrational number in the denominator. √2 is irrational, meaning not rational. And so they say we should rationalize the denominator. Okay, so the way that we do that it was multiply by root 2 over root 2, which is equal to 1. So we can always multiply by 1. And we multiply across here, we get negative root 2 over root 2 times root 2 is 2. And so this you're much more familiar with seeing on your unit circle. This is how they give it to you to memorize. For some reason, I don't understand that, but whatever. That's what they did. So we're looking for the angle that has negative root 2 over root 2. Now, anytime you see root 2 over 2, you know this is going to be some odd multiple of pi over 4, or 45 degrees, okay? So this is going to be one of those angles. So let's let's use our beautiful perfect circle. And I do have a ruler tool, but I'm just going to sketch these lines. Okay, so the 45s are the middle of each quadrant. All right. Now this pi over 2 is actually a multiple of pi over 4. It's 2 pi over 4. We don't want to include those because that's going to have 0, 1 as its coordinates. We want these guys. This is root 2 over 2 and root 2 over 2. Okay, and this is going to be negative root 2 over 2 and root 2 over 2. Now this is going to have both negative root 2 over 2 and root 2 over 2. And this is going to have, oops, it's negative as well. This is going to have just the y negative. So this is going to be root 2 over 2 and negative root 2 over 2. The reason why is it's just the symmetries of the unit circle. It's symmetric about the origin, and it's symmetric about the y-axis, it's symmetric about the x-axis. It's a really beautiful system here. Okay, so we are doing D now, and so we want the sine of theta to be negative 1 over root 2, which is equal to negative root 2 over 2. The sine corresponds with the y component of these ordered pairs. So where is sine negative? Well, it's this one and it's this one, okay? So we need to know what the corresponding angles are. Well, it's this angle and it's this angle. Okay, so this is 180 plus 45. Okay, and this is 360 minus 45. I guess I should put degrees for these guys. All right, so these are going to be our reference angles. These are our reference angles. This is 225, and this is 315. Check that, yes. So let me collect these up here, 225 degrees and 315 degrees. And then we'll figure out the rest of them in this domain that we're given here. All right, so what is the period of the sine function? What is one period of the sine function? It is 360 degrees. So we'll use that same trick that we used with part A and B of this number 2 here. I'm going to subtract 360 from each of these. So 225 minus 360 and 315 minus 360. This one is negative 45. This is negative 135. Yes. So we'll collect those two angles up here on our list, negative 45 degrees, negative 135 degrees. And then same thing, so we need to go to the next cycle after 0 to 360, which is 360 to 720. So we'll add 360 to both of those. And then 315 degrees plus 60 degrees. So this is 585. And this is 675. Okay. Yeah. All right. And so these are your answers for part D. So it's getting a little faster, a little faster. And actually, I'll leave that up for a second if you're copying furiously. I don't know if you're able to rewind on this now, but definitely once I stop, which actually I'm probably going to stop after this problem for at least a little while. Once I stop this, you'll be able to go back. It'll post it to YouTube and you'll be able to go back and look at everything. Okay, so now we're going to do E, which is the same question but for cosine. Okay, so let's bring back our unit circle so we can think through this. All right, so we have cosine of theta equal to -1 over 2, root 2. Now, same thing as before, we got to rationalize this. We don't have to rationalize this. It will be easier for you to see what they're talking about because you've learned everything in terms of root 2 over 2. So we got to realize that this is whatever cosine of theta, whatever theta that gives us negative root 2 over 2. Okay? All right. And anytime we get a root 2 over 2 or a 1 over root 2, we know that that is going to be our 45s or our pi's over 4. Okay? So those are in the middle of our quadrants. Now, it's negative, right? And we're talking about the cosine. Where's cosine negative? Wherever the x is negative. Cosine is the x. So that's the second quadrant and the third quadrant. And so that's here, and that is here. Okay? So this one is, this is 180 degrees. So we can go to 180 degrees and go back and we'll get there, or we can go from 90 and go forward and we'll get there. Either way. So I'll do 180 minus 45, and then 180, so here's 180 plus another 45 gives us that angle. All right. So this is 135, and this is 225. Okay, so let's collect those, collect those up here. 135 degrees, 225 degrees. Boom. All right, so this is in our first cycle from 0 to 360. Let's do the negative 360 to 0, the one before this. The way we'll get that is by subtracting one cycle of cosine, which is 360 degrees. Do the same thing here. Okay, so what is this? So that's going to be 225, negative 225, and then this is going to be negative 135. Okay, so we've got negative 225 and negative 135. Sorry, my handwriting is not trying to go fast. This is not super readable. And then to figure out the third cycle, or the 360 to 720, we're going to add 360 to each of these. Why 360? That's one period of cosine. Okay. So we've got 135 degrees plus 360 degrees and 225 degrees plus 360 degrees. So this is 495. We have 495, yep. And 585. And then if we added 360 to either of those angles, we would be outside the 720 upper bound. So these are our solutions for D, or for E rather. Okay, so this one's going to be our last one. This one's probably going to be the same amount of work as this guy, which is more than we want to do, but whatevs. We'll do it. We love math. Is your hand cramping? Let me know in the chat. Talk to me. Tell me what's up. Also, please subscribe and like and all of those things. Comment. They help me improve the channel and hopefully other people will notice it. I'll stop doing this for free at some point. I also have a Patreon if you want to send me $1. Okay, so we want the tangent of theta equal to negative root 3. Now, I'm going to do the same trick, right? The definition of tangent of theta is sine of theta over cosine of theta. This is an identity, okay? Now, I know that I can get some kind of a cancellation here. I want root 3 to be in the top. So root 3 over 2 over 1/2. I know that there are lots of angles of theta that give me this ratio. And I can either have this, the sine negative, or I can have the cosine negative. All right, so there's going to be 2 quadrants that solve this in the first cycle. So let us draw up our unit circle again. And this time I just want to use the ruler tool, because why not? All right. Honestly, this is why I don't use it, because it's like a little finicky to get it exactly where I want it. I wish it would just snap to those angles, but you know, it's such a good free tool that I shouldn't really complain too much. Okay, so sine is in the numerator. So where is sine root 3 over 2? Those are our 60s. Okay, these ones. But we want sine, in this one we want sine negative, okay? These give us sine negative. So we're dealing with just this fraction, sine negative, but we want cosine positive. So that's going to give us this angle. Now in this one, we want sine positive, cosine negative, and that is this angle here, okay? And this is pi over 3, this is pi over, so pi over 6, pi over 3, okay? So 90 plus pi over, I'm sorry, I think I said that backwards. This is pi over 3, this is pi over 6. So 90 plus pi over 3 gives us this angle. So here's 90, and here's another pi over 3. And then this is 180, 270 plus pi over 6, or plus 30 rather, which is 300. So 90 plus 30 is 120. And then 180 plus 90 is 270, plus 30 is 300. And quick sanity check, this is 120 plus 180 is 300. So that follows our period of tangent being 180 degrees. So we're good with that. So what we can do is we can just subtract 180 from this twice. So 120 degrees minus 180 degrees is negative 60 degrees. And then negative 60 degrees minus 180 degrees is equal to negative 240. And if we subtracted another 180, we'd be outside of that negative 360 lower bound, so we're not going to do that. Okay, there we go. Now we're going to add 180 to the 300. And 180 is the one period of tangent, and you know, it's good to like work through that and figure out why that happens, especially understanding why the asymptotes occur where they do. You know, and post a good question and I'll try to answer it regarding that, make a video for you just on that, but otherwise just memorize those periods. Sine and cosine and secant and cosecant all have a period of 2 pi or 360, and then tangent and cotangent is pi or 180, okay? So either memorize it or just work through it. It's illuminating. You know, you'll understand it a lot better. So this is 480, and then we do the same thing, 480 plus 180, or you could do 300 plus 360. This is going to give us 660. And then if we added 180 to this again, we'd get 7, 840, which is outside the range. So we know that this is all of our solutions. Okay, so good question. Hopefully I helped you. If I did help you, please subscribe to the channel. Trying to get my watch hours and my subscribers up. It'd be a YouTube math sensation. I'm like talking to you in the chat. I should probably look at the camera. That's why I'm not going to be a YouTube math sensation. Yeah, and if you have any other questions, you know, just message me or post it. I have a subreddit. You can check my post history on my Reddit username. Post it directly to me if you want. I'll make you a screencast video. Tell your friends if they get stuck on their homework, they can post questions to me as well. And hopefully it'll just be a lot of this, more of this, since I'm trapped inside for the coronavirus with all y'all. And otherwise, enjoy your mathing. I'll be back on later if you got more questions.